I assume you can. I don't need to tell you that white dot is the Earth. It's where we all live. And Seoul is somewhere on that white dot. There's a wonderful YouTube video by Carl Sagan called Pale Blue Dot, in which he talks about what it means to see the Earth from remote space. Let's keep going, larger scale. Most of you are science educators. This will be familiar, so I won't take a long time on it. We are about 2/3 from the center of the Milky Way. How big is the Milky Way? Our next door neighbor, Proxima Centauri, it's the closest star to us. Yesterday I flew for 9 hours from Sydney to Seoul in a jumbo 747. If I were to fly to Proxima Centauri in a jumbo 747, it would take me about 5 million years. That is getting to our neighbor. How many stars are there in the Milky Way? There are probably 400 billion. And there are hundreds of billions of galaxies. How much is a billion? It's just a number. It doesn't mean anything until you start thinking. If you tried to count every star in our galaxy, 1 star a second, it would take you 11.5 days to count the first million. It would take you 1,000 times as long to count the first billion. That's about 32 years. And it would take you almost 13,000 years to count every star in our galaxy. That's how huge our galaxy is, and there are hundreds of millions of galaxies. Now, this perspective is very important for students to understand. And it leads us to another definition of big history. What is big history about? It's about our place in the universe. So that means it's asking what is distinctive about this Earth and its inhabitants. It sees human history in a cosmological context. And that is a wonderful way of thinking about what we are and what we are as a species. Okay, second, interdisciplinarity. I'll deal with this very quickly. Big history courses are interdisciplinary. They go beyond human history. This is a coherent narrative. It touches on, let me read the list: cosmology, physics, chemistry, geology, biology, anthropology, history, literature, environmental studies, religious studies, and I could go on very easily. This is genuinely interdisciplinary. It's not a science or a history course. It brings the two together. It breaks down, I believe, the divide between the humanities and sciences. Now, the third distinctive feature I'd like to talk about is that big history is universal. Talking about universal history has been very unfashionable for a long, long time. But big history has the universality of an origin story. So let me explain what I mean. This is a personal definition of big history. It is a modern origin story, a unified history of the universe, the earth, and humanity on the basis of modern scientific scholarship. What are origin stories and why are they so powerful? Most human societies that we know of have taught origin stories. If you went to school in Australia 500 years ago, you would have been taught an origin story. You would have been taught where everything came from. And the end result would be that you would know where your place in the universe and amongst humanity. Origin stories give students an overview of all of knowledge so they can map themselves onto the universe. Now, why are they so important? This is a slightly sentimental way of thinking about it, but it might be helpful. An origin story gives you the view from the mountaintop. Let me explain. Learning is like exploring a new country. Teaching is like leading people through a landscape. Modern education describes many different landscapes: the landscape of chemistry, the landscape of biology, the landscape of history, but it rarely takes you to the mountaintop. From the mountaintop, you can see how all the landscapes fit together, and this is really important. So the goal of big history is to take students to the top of the mountain. From there, you see less detail, but you see how many different landscapes fit together. And then, when you return to your home landscape, you will understand it in new ways, and you will think about it in new ways. A year and a half ago, I visited Chamonix in the French Alps. Here's Chamonix close up, and here is the view from the mountaintop. I didn't climb to the top of the mountain, by the way. I got that from the internet, I'm afraid. I'm ashamed to confess. Okay. So that's an introduction to some of the things that big history is. Now I'd like to talk about some themes in big history. What do we talk about when we teach big history courses? Well, very quickly, let me describe the contents of the course I teach. Here are the main topics. We talk about the origins of the universe. So I lecture on Big Bang cosmology. I cannot tell you what fun that is for a historian. We talk about the creation of stars, galaxies, and chemical elements. We talk about the creation of the Earth, the Sun, and the solar system 4.5 billion years ago. We talk about the origins and evolution of life on Earth. We talk about the evolution of our own species and about human history as a part of this story. And finally, we talk about the future. We ask, where is it all going? And that is a question that my students are dying to ask. Now, how do you find coherence in a story like this? Well, it turns out it's not hard to find coherence at all, and we shouldn't be surprised, because modern knowledge is not fragmented. There is a unity to it. Here's one of the themes that we have found most powerful. It is increasing complexity. Let me try to explain this. As science teachers, many of you will know about the notion of entropy, the second law of thermodynamics. Now, naively, what that law says is that the universe as a whole tends towards simplicity. It's like a ball running downhill. But we also know that in certain environments you get Goldilocks conditions, special conditions under which suddenly the energy of entropy drives things uphill, and suddenly new, more complex things appear. Now, so we can tell the story of increasing complexity over 13.7 billion years, and this is very important for us, because modern human society is surely one of the most complex things we know. So to understand us, we need to know the story of increasing complexity. Now, this is something I talked about in a TED Talk, which should not be hard to find if you're interested, and that TED Talk was really about this story of increasing complexity and how how powerful it is for students. So what is complexity? Here's a very simple, naive definition. Complex things have lots of bits and pieces. Those bits and pieces are linked together in very precise patterns. There are energy flows. If you're talking about complex things that are not in equilibrium, that can evolve and change, there are energy flows. There are new emergent properties. Forgive me using this technical phrase, but it is so powerful. Emergent properties means that suddenly we see a new quality. Something that didn't exist before seems to exist. So this always seems magical when new things appear. And finally, complex things die. Eventually, entropy gets them, and they die. Complexity exists at many different scales. I'm not going to even try to get you to guess what these are. That's the brain tissue of a cat. That is a supercomputer simulation of a clustering of galaxies. We see complexity at multiple scales, at all the scales we talk about in big history. Now let me talk briefly about emergence, the idea of emergence. The best account I know of emergence actually comes in a Buddhist sutra, The Questions of Milinda. Now I'm not going to read it. I'm going to give my own description of what really happened here. Milinda was a Greco-Bactrian emperor about 2,200 years ago. And he became interested in Buddhism. But he was puzzled by the Buddha's idea of the self, because the Buddha said the self does not really exist in some sense. So Milinda called a great Buddhist sage, Nagasena, and they met probably in modern Afghanistan. And Nagasena said, "Sire, how did you come here?" And Milinda, his proper name was Menander, he was a real figure, by the way, said, "In a chariot, of course. What do you expect?" I mean, it's like saying in a limousine, you know. in a chariot. And Nagasena says, you can read this here, but this is my summary. What is the chariot? Is it the pole? Is it the yoke? Is it the reins? Is it the goad? And Melinda says, no, the chariot is all of those things together. And Nagasena says, yes, and that is what the self is. When you put all the bits and pieces together in the right way, you get something new. You get a chariot, or you get the self. This is a beautiful description for me of emergence. There's nothing magical about it. You just put things together in the right way, and something new appears. And big history is full of emergence, increasing complexity. Here's the story. The universe began very simple. There were clouds of hydrogen and helium atoms. There was the cosmic background radiation, electromagnetic radiation. There was dark energy and matter, which we don't understand. It's very simple. There were no galaxies and stars, no heavier chemical elements, no planets, no living organisms, no humans. And then, over 13.7 billion years, more complex things appeared, one by one, building on each other. Today, most of the universe is still very, very simple. But in pockets, little areas, particularly around stars, which provide the energy you need, we find complex things, such as ourselves and soul and the jumbo jet that I flew in yesterday. Now, when I teach, we focus on a number of threshold moments when suddenly new things appear, new things emerge. And here are the main ones that we focus on: the appearance of the universe, the appearance of stars. Stars were the first large, structured entities, and they had the emergent property of pumping energy into the cold of nearby space. The creation of new elements in supernovae and dying stars, the formation of the solar system and the Earth, the appearance of life on Earth. Threshold 6 is the appearance of humans, and I'll come back and talk about that in a minute. This, I believe, was a fundamental turning point in the history of our planet, and I'll explain why. Then the appearance of agriculture, then the appearance of today's world. How many of you are familiar with the term Anthropocene? Because it is becoming a more and more common way of describing what makes today's world different. And I'll come back to the idea of the Anthropocene. It says that today's world is different because for the first time, one species, our own, is the dominant force for change in the biosphere. We are very, very powerful. Now, let me give you some idea of timelines, dates. Most of us cannot deal with billions or millions of years. So let's imagine the universe began 13 years ago. Okay? We've compressed everything by 1 billion. The Earth would have existed for about 5 years. This timescale will give you some feeling for the shape of big history. The Earth, in other words, is more than 1/3 as old as the universe. Large organisms with many cells, we're talking about the Cambrian Revolution, would have appeared 7 months ago. The asteroid that killed the dinosaurs, how many of you are aware that an asteroid wiped out the dinosaurs? I hope as science teachers that most of you are. But this is very, very important in big history.